Hey there, Gregory Carlson here, and we just learned this incredible new rule, which is the power rule, which says that if you have f of x is equal to x to some power, then that means the derivative function is equal to n times x to the n minus 1. So you basically bring the n out in front, and you just drop the power by 1. So let's apply that. Find the derivative of f of x is equal to x to the 8. Well, the derivative of that would just equal, bring down the 8, x, drop the power by 1. And that's it. That's the derivative. And it's just incredible because think how long that would have taken with the definition of the derivative. You'd have x plus h to the 8th power, which would be really, really long. It would take you forever to FOIL that or use the binomial theorem. So it's really just that simple. So let's do the next one. Find dy dx, so you can see that we're using Leibniz's notation. And we have our function y equals 8x to the 8. So what I would write is dy dx is equal to. Now, we're taking the derivative of this function. So I'm going to write d dx because we're taking the derivative with respect to x, okay? And so remember, we have the multiplication rule, so I can factor out this 8 and pull it outside of the derivative, like that. So I can take the 8 and pull it outside of the derivative, and then we're just taking the derivative of x to the 8. And we know from the previous problem what that derivative was. So this would just equal 8 times the derivative of x to the 8, which is just 8x to the 7. And now we're pretty much done. So therefore, dy dx, our final answer, we have 8 times 8, which is 64, x to the 7. So on this problem, you can see that I showed all of my work. I took the derivative, I pulled the 8 out in front, then I took the derivative of x to the 8, and then simplified a little bit. However, as you get better at this, you might be able to just do mental math with this. Bring the 8 out in front. It multiplies by whatever you have in front. So 8 times 8 is 64, and then just drop the power by 1. And so you can pretty much do these in your head. By the way, the power rule, x to the n, works even if you have a negative number. And although I didn't prove that, I might prove that in a separate video, this basically works for any exponent. So let's do it. dy dx would equal the derivative with respect to x of 7x to the negative 4. And notice I said with respect to x. A little later, we're going to take derivatives with respect to different variables, but we're not going to worry about that for right now. So once again, I can pull the 7 out in front. And I have x to the negative 4. So we can pull the 7 outside of our derivative, and so now let's do the next step. What would the derivative of this be? Well, we just apply the power rule, which will be 7 times, you bring the negative 4 down, and you drop the power by 1, which, by the way, would be negative 5. So that sometimes trips people up. Remember, when we're taking the derivative and using the power rule, the exponent drops by 1. So 8 fell to 7. Negative 4 would drop by 1 down to negative 5. So therefore, the answer would be dy dx equals 7 times negative 4 is negative 28, x to the negative 5. And it really is as simple as that. So notice that if we're doing the power rule and we have a negative exponent, our answer's sign will flip because we bring down that negative sign. Let's do some more examples. This is a great one. Differentiate y equals 3x to the 3 minus 14x squared plus 32x plus 9. If we tried to use the definition of a derivative, this would take forever. And so I'm not even going to show all of my work to this. We're going to use the power rule. And we're going to use the addition rule, which means we can just take the derivatives of these things separately. So what's the derivative of 3x to the 3? Bring the 3 down. That would be 9x to the 2. Okay, so that would be 9x squared. What about the next one? Minus 14x squared. What would the derivative of that function be? Well, you just multiply 2 times 14, which is negative 28. and then you would just drop that power by 1. So 2 dropping by 1 would be x to the 1. Now, what would the derivative of the third term be? Well, we remember that I talked about how if it's just a linear term, the derivative of that is just the number, it's just the slope. But it also kind of works with the power rule, because if you think of x of just having a power of 1, 32 times 1 is 32, and then you would drop the power and just have x to the 0. Do you see that? And so then finally, this plus 9, what's the derivative of that constant? Well, the derivative of a constant is just 0. Or in fact, you don't even need to write anything. So just cleaning that up really quick, dy dx, the derivative of this function would be 9x squared minus 28x plus 32. And that's it. Dy dx would just equal, I mean, you can pretty much do that in one step in your head. Even though this is a 4-term cubic function, you can pretty much find the instantaneous rate of change anywhere on that function, basically in one step in your head. It's just incredible. So let's find the derivative of 1 over x. You'll remember I already did this one with the definition of the derivative. It took about 8 steps. So let's see how many steps it takes if we're using the power rule. So first you should rewrite this as y equals x to the negative 1. Do you agree with me that 1 over x is the same thing as x to the negative 1? And so now we can do the power rule. So you bring down the negative 1 and drop the power by 1. And so we get negative 1 x to the negative 2 because we dropped that negative 1's power by 1. So now let's go ahead and move that back into the denominator to make it a positive exponent. And you see what the derivative is. So we can get there in very few steps with the power rule. Negative 1 x to the negative 2 becomes negative 1 over x squared. So I've got time for a few more examples. Let's do this one. Find f prime of x if f of x is equal to 5 over 6x to the 3. So we're finding the derivative of this. So f prime of x would equal d dx, the derivative with respect to x, of 5 over 6 and x to the 3 on the bottom. So again, what I would do here, that's a 3, I would go ahead and factor out this 5 over 6. We can do that. We can factor it out of the derivative. So that would equal 5 over 6 times d dx of 1 over x to the 3. Okay? So now let's go ahead and rewrite 1 over x to the 3. So this would be 5 over 6 times d dx of x to the negative 3. So I rewrote it as a negative exponent because now we can apply the power rule. So this fraction would equal 5 over 6 times the derivative of x to the negative 3, which would be negative 3x to the negative 4. Just like that. We just took our derivative, and you can see, notice the negative 3 came out in front, and negative 3 dropped by 1 to make negative 4. So let's cancel 3 and 6, and so that becomes a 2. So the answer would be negative 5 over 2 x to the negative 4. And let's rewrite that one more time so that it has a positive exponent. And there you go. So I just showed all of my steps. As you get better at this, you might even be able to go from here to here in your head if you're really clever and if you're careful about your signs and cancellations. So let's make a general rule. If I have f of x is equal to 1 over x to the n, then that means the derivative is simply going to be negative 1 over x to the n plus 1. Okay? So that's just kind of a general rule you can memorize, just an extension of the power rule. Notice that if you have x to the n in the denominator, this is going to be, the sign is going to flip. The sign is either going to go from positive to negative or negative to positive. And the reason for that is because when we move this x to the n up, it has a negative power. And when we bring that in front, it's going to carry that negative with it. So that's helpful to remember. And there's one final application we can do with this. This will also work for helping us find the derivative of the square root of x. because as you'll remember, we can rewrite that as x to the 1/2 power. And now we can apply the power rule. So let's do it. The derivative is going to equal, you bring down your number, and here we're going to be careful, we subtract 1. So you bring down your 1/2, and then it's the power minus 1. So that would equal 1/2 times x to the 1/2 minus 1. That's just going to be negative 1/2. So 1/2 minus 1 is negative 1/2. So that would be equal to, let's go ahead and bring that down so it turns the exponent to a positive. So that would be 1/2 times x to the 1/2. And finally, that would equal just 1/2 square root of x, because x to the 1/2 is the same thing as the square root of x. So this might even be a good one to memorize. If f of x is equal to the square root of x, with the power rule, we can see that the derivative of that, and I forgot my negative sign, whoops. So when we do that, no, I shouldn't have a negative sign. I'm sorry. I was confused there for a second. It was positive 1/2, so I do not have a negative sign to bring down. So if I have f of x equals the square root of x, the derivative of that is just 1/2 root x. And there you have it. So if they say find the instantaneous rate of change at the value of 6, all you need to do is just plug in a 6 right there. So the instantaneous rate of change at the value of 6 would just be 1/2 root 6. And you could plug that into your calculator to approximate it. Your homework might get mad that we have a square root of 6 right there in the denominator. So if you wanted to, you could simplify this by multiplying top and bottom by root 6. And if you did that, you'd get a final answer of the square root of 6 divided by root 6 times root 6 is just 6, and 6 times 2 is 12. So that answer may be a little bit more simplified so that we don't have a square root in the denominator. But remember, these two numbers are the same. So hopefully you see how easy these examples are with the power rule, way easier than trying to take these derivatives with the definition. We'll look at some more examples in the next video, and I will see you there.